Jayshree, thank you so much for spending the time with me today. Can we talk about your journey towards AI networking?
Sure, Alan, and thank you for having me. I know you've traveled far and wide to be here, so thank you. Look, our AI journey, we're still in the beginning of the journey, in my view. 2025 will prove to be a critical year. But when I think of our journey, I think it's less than 3 years old. It was probably a critical milestone in November of 2022, and ChatGPT became the rage, and AI sort of came from the back of the labs to the front end of all our networking experiences. And I think Arista found itself smack in the middle of this exciting adventure for two reasons. One is, there's the consumer type companies, the large cloud companies where every eyeball advantage can be a huge one, even if it's a nanosecond or a millisecond, if you can apply the right AI training. And then there is the enterprise advantage, where AI can be a critical co-pilot to many of your applications and just make them much more efficient. And the key to both of those is a mission critical network. So I would say our journey really started in late 2022. 23 has been a year of trials, and 24 and 25 will be, I think, the most important years for pilots in production.
Got it. And can you talk about how your customers are approaching AI?
Yeah. So first of all, I think we like to think of AI as sort of two different use cases. There's networking for AI and how we build a very mission critical network, low latency, high radix, high scale, all of that good stuff that resonates with Arista customers, because we are the high performance network. And then there's AI for networking, which is how is it we in Arista are leveraging AI, and we do this through something we call autonomous virtual assistant to make security better, troubleshooting better, observability better. And these to us are two different use cases, one for really the top AI, largest, baddest clusters in the world, and the second for more security and observability.
Got it. What was the moment when you realized for Arista that AI was going to be a big deal?
Yeah, that's a good question. My aha moment actually came, you would laugh at this, at a optical fiber conference, OFC. I think it was OFC 2023. Andy was like, "Oh, you have to do the keynote for this." I said, "Andy, the audience will know more about AI and especially optical than I can spell. What am I doing here?" And so I was largely going to be talking about our optical directions. But what was going to be more about optical directions ended up being sort of an AI optical talk, because one of the big drivers, even for optics and of course switching, was AI. So January of 2023, I gave this talk on how AI and the large language models and the vectors of GPUs was heading towards terabit capacity switching, and that was going to be driving a lot of optical capabilities. Co-packaged optics was one way, but linear drive optics and what we introduced as linear pluggable optics, LPOs. But that conference, while mostly an optical conference, ended up being my first AI talk. And I still remember the CFO said, "What did you say in your talk? Because our stock has gone up a lot." And so that's when I realized, this is an aha moment for AI. And people are realizing this is a killer application for everything, including networking.
Yeah, for sure. I mean, for me, it was when we realized there was going to be a back end and a front end network.
Yes.
So you kind of got this multiplicative effect
Yes.
of how many ports, or even more so on the bandwidth side.
Yeah.
It was like, okay, this is going to be a big deal.
Yeah, that was
right?
pretty crazy, because Arista until now has not participated in the back end. We're starting from zero, right? And back end has typically been PCIe or CXL, or if you're in a rack, you may use some NVLink technologies. And then Infiniband, which was largely a high-performance compute technology. So from our perspective, AI really arrived in the back end when we could show that Ethernet had good latency, good real-time performance, good congestion control mechanisms, good packet spraying techniques, all the way down to the neck. And to me, another turning moment for AI and Arista was the formation of the Ultra Ethernet Consortium, because Arista, as a co-founder, along with many established vendors, was out to prove that Ethernet once again can can beat out alternate technologies. I'm not a big fan of Ethernet technologies, but I think Ethernet, every step of the way, manages to stretch itself and do things, and of course have the advantage of the economics and the large install base to make, in this case, back-end networking better.
Yeah, it's incredible. If you think about, like, in the US, there's
Yeah.
over one data center port per human in the installed base.
Is
Just
it
in
that
the
way?
US.
Wow.
It's that big.
Wow.
It's just an incredible.
Shows our humans are decreasing in population, right?
Yeah. And not just data center, let alone all the other areas.
Yeah, no, you
can
bring up a really good point, because I think the advent of workloads and machines is greater than humans. The advent of clients and IoT devices is also greater than humans. So, there is an element of, geez, our population shrinking, but it definitely seems like our population is using a lot more devices and machines per person, right? Per
Yeah.
capita.
Yeah, it's amazing to see. Can we talk about how is Arista developing platforms for AI, and kind of like what's different in AI than when you were doing cloud or kind of high performance in the past?
Yeah, now this is a very thought-provoking question. Let me step back and say, why is even Arista relevant for AI? And I think then there are three things that make Arista very relevant for high-performance cloud networking in the data center, or what I now call centers of data, because AI is very data intensive and compute intensive. And so you can build a data center, or you could build an AI center, or by the way, those centers of data can be for the wide area or campus or branch as well in the enterprise, right? So I think one at the heart of Arista's soul is our software architecture. If you don't build good software, then you can throw together a bunch of, hardware, and it may be short-lived. So as you know, Arista, you've been tracking us and following us from day one. We started with this publish, subscribe, state-oriented model, which had been done in the Unix systems and computers, but never been done in networking, where you could separate the state and the data plane and the management plane and the control plane, and really allow all of this to come alive with different agents, right? Then we took that sysdb architecture and provided it network-wide with what we call NetDB, so you could manage not just a single switch, but multiple switches. But probably the advent of AI really made us think about a NetDL, a network data lake architecture, which, if I remember right, we did that even before the 2022, probably November 21. So we first built that architecture. And what's NetDL? Network data lake is a way for us to have multiple domains of data. It could be structured data, unstructured data, flow data, and we bring in all of this Kafka, HBase, ClickHouse capability along with our publish subscribe model. So all of a sudden, networking wasn't just about connectivity, it was about connecting different forms of data, which you have to do in AI. And probably the biggest data form in AI is flow-based data, because the diversity of the flow is super important. The fidelity or entropy of the flow, because you can have large elephant flows, you can have small, long-lived and short-lived, is very important too. So capturing all of this in an architecture was very important. And even though EOS is, I like to call it, you could argue it's 15 years old, I like to call it 15 years new, because every 5 years we're changing the architecture and adding more features, right? So this was, I think, a key part of our platform. The second piece is obviously performance. And the first place we saw our AI networking come alive is what we call the AI spine. The 7800 was a flagship product. You could get 576, wire speed, at that time 400 gig ports, now 800 gig ports, and in the future 1.6 terabit ports. And you could see what tremendous scale and capacity, fully non-blocking, virtual output queuing, the right buffers and high bandwidth memory to deal with this, the right management of collision, throttle when you have to send it off without dropping packets. So this became our first product that people, our large customers, started trialing to say, can Ethernet do the job? Or, can we be an alternative? So the AI spine allowed them to build, 1,000 node GPU clusters if you had two of them. And then there was the portfolio approach, which is, okay, you can build a spine, you can build the right software, but how do you really build a GPU cluster that goes from 1,000 to 50,000 to 100,000 to, in the future, 1 million? And this is where a multi-tier topology with different kind of leaves came in. One of my favorite, we now have 20 products in our portfolio, but one of my favorites that we defined and developed in conjunction with Meta was the Arista 7700 platform, which was a distributed Etherlink spine, where we took that leaf spine, AI leaf, AI spine architecture, and literally brought it into one single stage fabric where you could still retain the buffer and the congestion control advantages, but now you could optimize it for a specific cluster size, typically 9 to 10,000 GPUs. So I think these three advantages wouldn't be possible if you didn't also offer the right visibility. Like, job completion, as I told you, is extremely flow dependent, and you could be waiting and waiting and waiting for the last flow. So visibility becomes very critical for these large training workloads, because you don't want to be sitting there and sipping coffee while this training workload's going on. So I think Cloud Vision plays a pivotal role in offering that visibility. And one of the other neat things we did that we showed at our 10th anniversary celebration is the visibility can go all the way down to the host. And you can actually look at, Broadcom NICs or ConnectX NVIDIA NICs, or in the future, third-party NICs, and not only get network-wide visibility, but all the way down to the host.
Yeah, I think that customer collaboration is important. Can we kind of dive a little bit more into that without spilling any secret sauce there? But when you were working with, say, Meta, because that was what you mentioned, how exactly does that work when you do collaboration there and innovate on something that is so bleeding edge?
Yeah, no, let me go back to our cloud days, because this is not the first time, right? So we've been working with customers like Meta and Microsoft and so many others to really understand their needs and our needs. And what I mean by that is a standard product with our EOS would fit a more standard customer. But let me take the Microsoft example. They are big fans of a huge Azure cloud with multiple data centers, but one size doesn't fit all. In some cases, they have smaller regions with T0 networks. In other cases, they have T1, T2, and they have a wide area connection to bring all their data centers together. So one of their important requirements, even before we enter AI, it was, we need Sonic. And anybody else would have looked at this and said, well, Sonic, we don't do that, we do EOS. But we worked with them closely on the Azure stack to make sure that our hardware could not only accommodate EOS, but could also run an open source Sonic model. Now, that way they had the best of both worlds. So this was an example. Similarly with Meta, this is actually our third product we've defined together, because when they built FBOSS, which is their version of an open operating system, and they had the mini pack and the mega pack and all of these compute driven blades, they also needed a different approach. They needed, a very high density solution. They didn't always want the big buffers, but they needed to bring in all of this capability and capacity into one single chassis, again, supporting EOS and FBOSS. And during the supply chain, in fact, in many cases, they were even relying on us to do what typically a white box does, because they couldn't get the supply chain from their white box. So our collaboration goes, not just towards engineering definition and building products, but really looking at this from soup to nuts all the way down to the supply chain. We qualify optics. We make sure we keep track of the inventory. Now that both customers have such a huge install base, keeping track of just what they're doing where is, you can imagine, a work of art, a work of high quality, and a work of real distinction between all of these products. Now, let me fast forward to AI. With AI, I think many of these early networks, and both Meta and Microsoft have stated this publicly, the back end was Infiniband. Why? Well, it was just an old habit. You got the GPU, you hooked it up to Infiniband, and you were up and running. So it took a real concerted effort to work with them in understanding what the workloads would look like, what the job completion time would look like. And you could see on different packet sizes how the workload is optimized and improves even with some of the Ethernet characteristics, particularly with the UEC definition. So at the Ultra Ethernet Consortium, both Microsoft and Meta were present to help us define some of these things. And they made that critical decision to not just build their backends with InfiniBand, but slowly move to Ethernet. And that was an example also of joint work, right? Now, when you think of these things, I think you rightly pointed out, okay, you can build an isolated backend cluster with Ethernet, but how do you connect to everything else? That's where a lot of the front end work comes in, because a lot of the front end was one island, the back end was another. And, in the old days, you needed a gateway between them to do any kind of translation, and then you'd lose all the advantages of latency if you do that gateway. So the uniformity of Ethernet and building a very high performance cluster, and at the same time having the ability to transit to general purpose compute for indexing and querying and searching, or storage for large amounts of high bandwidth access, or the data center interconnect across the WAN are very good examples of the back-end AI and the front end really working in harmony together.
Yeah, absolutely. I think in the early days there was a lot of controversy between InfiniBand and Ethernet and a lot of verses.
Yes.
And it feels like Ethernet is the path going forward. You mentioned the Ultra Ethernet Consortium working
Right.
with some of the customers. Is there anything else there that kind of allowed Ethernet to take that, say, technology leadership role going forward?
Unquestionably, we were able to show some performance studies where we could get a 65% improvement using our Etherlink technologies, emulating a lot of the UEC features for congestion control, per flow queuing, packet spraying, etc. So this isn't even vanilla Ethernet. This is better Ethernet for the compute and job completion time. So, and I think you'll continue to see more improvements on this as UEC-based, standards-based NICs come out and hosts come out. So we live in a world where we claim standards, but there's an awful lot of proprietary things that sometimes have to be tuned and tweaked to make it work. And that's kind of where we are now. And I think as more and more the UEC spec is, should be out in early 25. As that happens, I think you'll see even more improvements than the 65% I was mentioning.
Yeah, I think the industry doesn't appreciate how many knobs there are to kind of fine-tune AI clusters. It's not just one sort of system that works.
This is a very good point, Alan, because I think if you listen to the compute vendors like NVIDIA or AMD or anybody else building AI accelerators, there's sort of the x-axis, which is, accelerated computing. And whether you have to do, latency optimizations or nickel drivers or things you have to do to improve the applications, AI applications running on compute. And that's sort of the scale-up paradigm, as I call it, right? And there's a bunch of things you can do to tweak it. But most of the things you do to tweak it are more on the compute acceleration side than they are on the I/O side. The I/O is a simple technology, whether it's a bus or a PCIe or But then if you need to do accelerated networking, and you start going from within a rack of GPUs to tens of thousands or hundreds of thousands, the scale out and the horizontal scale out becomes even more important than the scale up, or they at least go hand in hand. So while the compute vendors may work on accelerated computing, the networking vendors like ourselves have to work on accelerated networking. And then the x-axis and the y-axis can work together much more seamlessly. And that's where we play a role. We play a much stronger role once you get out of the compute and we have to connect all of these multiple compute pods and racks and really look at this as a professional production network rather than a Oasis cluster.
Yeah, I think there's a lot of confusion on the industry level. Like as we go to say 100,000 GPUs and then 1,000,000 GPUs, what exactly does that mean? And maybe we could ask that in kind of two parts.
Yeah.
First part, like as we scale out
Yeah.
to those huge numbers, what changes in that data center network in
Yeah.
order to have that in, say, the same facility?
Yeah. So again, I'll go back to the cloud roots because there's so many parallels over there, right? When you built back then, we didn't talk about 100,000 and million. Let's start with 10,000, right? In fact, that was the early days. What did we need to do? We built an active-active leaf-spine topology. Arista was the pioneer of this. And we used a technology called MLAG at layer 2, or you could do it using ECMP for layer 3. And you could go 12-way, 16-way, 48-way, 128-way, and you just keep widening the radix to get more and more nodes in, right? And there were two advantages. They're all non-blocking. You're not buying two of everything because you've got active links. If one fails, you may have some performance blip, but you'll still be able to take the load on the other, right? AI is similar, but at much higher speeds and much tighter latencies and throughput, right? So what we see there, once again, is now to build a 100,000 network, you've got to have, again, that leaf spine topology where the spine can carry the kind of capacity and density. I talked about 576, 400 gig ports. You should be able to go to 800 gig and you should be able to go to 1.6 terabytes. So two of these chassis can then connect to a whole set of n-way leaves, right? And you can build with that two-tier topology easily 100,000, without any compromises. What we've also noticed with a lot of customers is sometimes it's just not the throughput, it's the radix. So you may fan out with high speed throughput at 400 or 800, but you also want to go far and wide to improve your job completion time. So the parallelization is as important as the throughput. Now, if you want to go to a million, and people are still nowhere close to that. The largest networks are still in the tens of thousands. But as you go to a million, it is possible to do it multiple ways. One way is you add more tiers to the topology. So you can have a leaf, you can have a spine, and then you can have a multi-tier spine. Because again, you're improving the radix and you're adding n ways and a multiplicative factor kind of thing. It's probably more likely that the cost of that gets pretty outrageously expensive because every GPU is, $25,000 times a million GPUs. Not everybody's going to spend $25 billion, right? The more likely scenario is for these large language models, you will build a distributed class of AI networks where one of them may be 50, 100, and then you may go to 200, and but you're never going to build just one. Never say never, but generally speaking, not one AI center with a million GPUs, but more likely a distributed AI center that aggregates to a million GPUs, if that makes sense, right? That's the more likely practical thing for both redundancy. Also, some of these GPUs require heavy-duty cooling. So pretty soon you'll have switches swimming in water. So that's something to keep in mind, especially with the power pressures. The greatest pressure in AI centers or AI data centers is power right now. So one has to consider that. But the beauty of what this leaf spine topology is, you can scale out with multiple spines, or you can distribute it with multiple large language models and build clusters of them. I think there's going to come a time where inference or small language models will also play a role in the front-end network. And it may be difficult to distinguish whether it's an AI traffic or a video traffic or a data traffic or a cloud traffic. So I think AI will come in all shapes and sizes. Right now we're in the deep end of the pool, only worrying about the largest of training workloads, but that may change over time.
Yeah, no one ever thinks about if you had a million GPUs in one location, what exactly would that look like? I mean, would it be like a huge swimming pool? Would it be in Antarctica?
Football stadium.
Right, like what exactly would that do?
No, as I look into some of our early deployments, it's much larger than a swimming pool and much more demanding in power, right? So I think things will get bigger and better to improve the job completion time. With every ChatGPT application or Anthropic or whatever the new application is, I think you're pushing the envelope. But for every extreme there's also many use cases that may be more smaller, because today we're in the large cloud AI titan use cases. But if you start to see AI for the masses, then you have to start thinking of, okay, what's the use cases? What's the applications? Is it call agents? Is it HR applications? Is it, a specialized workday? So some of those efficiencies where you're trying to remove the manpower or people-intensive roles into more, bots or AI agents, if you will, don't require the same oomph that the job completion time of a large training Wikipedia would, right? So I think that you're going to see both of them thrive in those type of use cases.
Can we dive into those customer types a little bit more? So you talked to cloud titans. We kind of talked about them.
Yeah.
We've got enterprise, and we'll call them like mid-tier cloud there.
Yeah.
Are they all asking for the same thing, or to your point, is it a very
It's very different? Yeah. So when I look at the large cloud AI titans, as I said before, there are two kinds. There are those that are appealing to the consumer, and they're looking to get every nanosecond of job completion time improvement to get better ad or search or eyeball time. I mean, a second advantage is huge for them, right, in terms of commercializing. When I look at the large cloud titans through an enterprise lens, they're looking to provide more co-pilots and make OpenAI run better, or their job completion time across scale for these large data centers. When I look at the enterprises, they are smaller use cases right now. Nobody's rushing to do, large 100,000 GPU clusters there, although they well might when they find that vertical use case. What I'm finding there is smaller use cases, more experimental, looking for that killer application that might be coming soon and to be ready for it when they do. So, if you remember the way Content and Akamai and companies like that created a CDN network, I think there could be a AI version of that CDN network in the enterprise. But again, the killer apps are still emerging for that. So I'd say different strokes for different folks.
Yeah, I agree. I think it's kind of interesting because we're starting on the consumer side.
Yeah, we
But
are.
we all know the enterprise market is always the larger of the two markets. So it's finding those killer apps. And if it's HR, you could say that broadly is all verticals. But if it's
Absolutely.
something like drug development or
Yeah, that's
they're
another one
different.
too.
Yeah.
Genome sequencing. Those of them, I would still put more in the training because they would need to be looking at large amounts of data for that. So if they find a use case there, they'd probably look more like the cloud titans, right? In terms of pharma, search. I think the beauty of this is, we all knew how important data was. We never, I think, realized the full impact of how AI can make your data so valuable. And so the way we did it with Hadoop clusters or large databases, everything's getting challenged now. Just about every one of those companies has to you know s- reinvent themselves to make AI more efficient and possible for themselves. It's
Yeah,
pretty cool.
it's cool. You see that reinvention, and it's kind of like one of those industrial revolutions where
Yeah.
if you haven't reinvented yourself in 20 years, you won't be in business. But you don't quite know what that means yet. You're in that
Yeah,
experimentation
this
phase.
this is so true, Alan. Would you have thought that AI would come upon us so fast and so furious two
No,
years ago?
no,
No,
not
we
this
didn't
pace.
either. We In fact, this is an interesting statistic you will appreciate. When Arista first started and we were a 10 gigabit company, we felt like it almost took 10 years to go from 1 gig to 10 gig. But then the migration to 100 gig took a lot less time, probably 5 years. And the migration to 400 gig, thanks to AI, has taken half the time, 2.5 years. So if you extrapolate that, oh my God, it's pretty scary what the laws of physics and the migration in time is going to condense to for AI. But it's great. It's a lot of fun to be in high performance networking in the deep end of the swimming pool, even though I don't swim, and service these kind of mission critical customers. And that the speed waves are happening in half and half and half the time they did before.
Yeah, absolutely. I think that's a good kind of final question here. So, as we go thinking about ending 24 and going into 25, what advice could you give those customers, let's say those enterprises that are still in the experimentation phase, of how they can get that journey done faster or kind of accelerate their journey towards AI?
Yeah, I think I'd like to step back, Alan, and say it's not just about AI for these customers. They have to really step back and say, what are you trying to do with your network? When I look at enterprises, and I spent a large amount of my career in enterprises, I think the Catalyst switches are still the most popular products, may even be furniture pieces right now in some of those customers, but they've been around 20 years, right? And I go, what are they trying to do? And are we really helping them? I think in the early days, they were insourcing all of engineering and they were building everything themselves. And then everybody said, hey, wait a minute, you got to have a cloud play. And a lot of them moved their e commerce workloads to the cloud. And now you see, oh my God, they're spending so much money in the cloud. Some of them are thinking of repatriating back into the enterprise. So I come back to, ladies and gentlemen, it's not just about data centers. It's a building centers of data in your networking architecture, whether that location is a branch, a campus, a data center, or an AI, to your point, right? And if you put in the right architecture, then you can create, any packaging of it. A branch package or a PoE package, a wireless leaf, a compute leaf, a storage leaf, or an AI spine. And the key is to put in that foundation, and then you can renovate your house any which way you want it. I really feel that Arista in Greek means to be great, and you've been tracking us now for at least a dozen years, maybe longer. You said you saw us back in the Menlo Park building, so
Yeah,
that's
yeah.
15 years. When we were by the fire station in the basement of a garage, the the top was a lawyer's office. It was a 100-year-old office that went under. At the bottom was our little startup that kind of made it. And when I look at that, I see a parting of the seas. And what I mean by that is, on one side, you have established vendors like Cisco that are going in the direction of Splunk and observability. And, you know, networking's important, but they're doing other things like Splunk. And then on the other hand, you see companies like Juniper that were servicing the service providers now merging with HPE and trying to provide, sort of a consolidated approach. So the networking industry is consolidating. And in that parting of the seas, I think Arista is the only pure play innovator for AI centers, WAN centers, data centers, and campus centers. And I couldn't be more excited by the next 10 years as we launch and embark on Arista 2.0.
Yeah, it really sounds like the network is going to be more and more important every year as we go on, right? That's kind
It
of,
always was, but I think it's the lifeline, and it's becoming more mission critical for businesses
yeah,
today.
maybe businesses are noticing it more now than they did in the past.
Yeah, I like not to be noticed, because if you are, then maybe something went wrong. But definitely the silent heroes.
Awesome. Jayshree, thank you so much for the time today. We really learned a lot and looking forward to the AI and networking journey as we go into 2025.
Alan, thank you. So good to have you here
Yeah, thank you
today.
so much for having me.
Absolutely. Your questions were very thought provoking, and hopefully the answers made sense.
No, thank you.
Thank you.